Yesterday we introduced you guys with the whole complex numbers, talking about the values of I. We wrote out a lot of stuff about imaginary numbers, and the one thing that came up from it was that the square root of -1 is I. We agree on that, right? Yes. Now, the other thing that I want to start walking through is sometimes we can have different powers of I. Now, I'm going to write this backwards here. I'm going to rewrite this as I is the square root of -1.
Wow.
Is that okay?
No, my eraser doesn't work.
Now, guys, come on. What would I squared be? Think about what that means. I squared, very good. I squared is -1 because what you're doing is you're taking I times I, which is the square root of -1 times the square root of -1, which is square root of junk times the square root of junk is junk. So I squared is -1. What about I cubed? Well, remember, I cubed is the same thing as saying I squared times I. Remember your powers of exponents properties from a long time ago? When you're multiplying variables together, you add your exponents. Works the same way with I values, works the same way with integers, all that same stuff. So if I take I squared times I, well, what's I squared? -1. -1 times the square root of -1. Well, what's the square root of -1? I, so this becomes -1 times I, otherwise known as negative I.
What the heck? How can you make a measurements?
Hey, Mr. Jenkins.
I Jenkins!
Hey, can you sing your song?
Mr. Jenkins, sing your song.
Sing your song, Mr. Jenkins.
The
Ready, go.
opposite of b plus or minus.
X equals opposite b plus or minus square root b squared minus 4c
All over 2a.
That's an awesome skill kit.
Hey, Junkins, are you ready to get some good practice?
So,
Yeah.
Me too.
Brought 2 socks. Well, I did bring 2 socks. That's actually not a joke.
It's a good idea.
what about I to the 4th? See, Jenkins?
5. Kidding, I don't want to learn that. I already know.
What's I to the 4th be rewritten as I squared times I squared, right?
Oh my god.
Oh my God.
How much is I squared? -1. What's -1 times -1? 1.
Wait, is it negative? Can you go back up to like
This is not.
Isn't it just I?
This is not okay.
Now,
What? 1 squared?
what we're doing here is that I'm trying to show you guys that there are multiplication patterns that occur when you start working with I. I is always the square root of -1. I squared is I, which is negative, the square root of -1 squared, so it's -1. I cubed is negative I. I to the 4th becomes 1. Now think about what I to the 5th would look like. Isn't I to the 5th the same as I to the 4th times I to the 1st? Well, what's 4 plus 1?
7.
5. I to the 4th is 1 times the square root of -1. So this becomes I again. It repeats itself after every 4th.
What the heck?
Because what you're able to do then is say, hey, what is I to the 27th power? Well, if you think about it in terms of, if I take 27, take out every 4 of them, I to the 4th, I to the 4th, that's what, 16? Here's 20, 24, Well, I can't do 28, so I'll do 27. This much here, exponent-wise, is I to the 24th. Well, what's I to the 4th? 1. So what's 1 times 1 times 1 times 1 times 1 times 1? 1. And what's I cubed? So this equals negative I. Nope. The square root of negative 1 is I. This is, nope, because it's inside the radical. Because what's the square root of negative 1? It's not distributing in here. It's negative I. What I'm getting at here, guys, is that by utilizing just those 4 exponents, we're going to be able to mess around with simplifying and working with complex numbers via just combining like terms. We'll be able to multiply them together. We'll be able to divide them. We do all this other stuff. But in essence, really, all this is, to start with, is nothing more than combined like terms. Complex numbers are generally written as A plus or minus BI, where A and B are the integer values in front, like the coefficients, if you will. They always group them within parentheses. If you're using parentheses when you're adding, what would you do if this was 2 minus x plus 5 plus 4x? What would you do? Are you distributing anything here? No, because there's an addition symbol. You just combine like terms. It's 2 minus x plus 5 plus 4x. These parentheses are just what we call grouping symbols. It just means they're part of it together. They have no bearing to the problem here because of the addition symbol. So what's 2 plus 5? 7. And then negative x plus 4x.
3x.
So you would write it as 3x plus 7. Yes, ma'am? But what's different with i's, what's different when this becomes an I value, the I value is written last. That's it. All these are combined like terms, guys. So if I look at these two, oops, put these together. If I look at this, 4 minus I plus 3 plus 2I. Yeah, I'm starting over with this one. If I go back to this problem right here, since it's an addition problem, do the parentheses, do I have to worry about them? No. This is the same thing as saying 4 minus I plus 3 plus 2I. Combine like terms. What's 4 plus 3?
7.
What's negative 1I plus 2I?
1i.
Done. Go to the next problem.
That's
it.
isn't it?
We got multiplication we're about here in a second too. Thank you guys. I don't think so.
Will you like hold it over?
So
It's
natural.
like, you finish.
Don't do it right here.
Is this an algae bottle?
You get it, Taria?
Algae?
I have the same one.
We're like twins. Like Christmas twins.
No. Not really.
No.
What changes here? It's a subtraction symbol. When you have a subtraction symbol, the only thing you have to concern yourself about now is the fact that there is a 1 hiding there. And you'd have to send to both terms. That's it. You have to distribute the negative to both parts in that second part of the parentheses. That's the only thing you have to worry about. It's the same thing as associative property with addition and subtraction. That's all it is. So you get 7 minus 5i minus 1 plus 5i. 6. That's it. What's that? That's all we're worried about, guys. Today we're looking at combining like terms. It's a lot of combining like terms. That's all there is to this. Yes,
So
ma'am?
is this our homework?
It's a 5. Okay. So take a second and try this one.
Holy cannoli.
Take a second, try that one.
Okay.
We gotta get flying here, guys. You're running behind already. Go figure. Yeah, that's okay. Oh, real quick. I did say that I have the big book of answers online. I cannot find my PDF files for chapter 5 anywhere. So what I'm going to do is, this is the big book of answers. By all means, if you ever want to take a look at it, it's the worked out solution key, so it tells you how to do all the problems. I'm going to keep it in the cabinet right here. Right there. Big book of answers. Make sure it goes back in there. Here. Yeah. So anytime if you want to check an answer between class periods or before you go home, if you want to take a picture of it to make sure you're doing it right, it's always open. It's there for you to take a look at, okay? Remember, your final answers are always going to be integer value, and then i's are last, okay? So you just rewrite this. It becomes 6 plus 2 minus 9i, because I'm distributing the negative to both parts. I don't have to distribute anything here, so I just rewrite it as negative 8 and plus a 4i. 6 plus 2 is? 8 minus 8 is?
0.
Negative 9 plus 4 is?
Negative 5.
You're done. Negative 5i. Combine like terms, ladies and gentlemen. That's all it is. We're going to multiply still and divide. Okay? Let's try another one. So you have 5i times the quantity negative 2 plus I, which means we have to do what? Distribute. Multiply. Yeah. Of the variable. Until you get to this. That's it. So distribute out. What's 5i times negative 2?
Negative 10i.
What's 5i times I? But what is I squared? Negative 1. That's why we go back to be able to do that. So it becomes negative 10i plus 5 times negative 1. So your final answer would be negative 5 minus 10i. Oop, square root, sorry. Yes, sir.
Are we allowed to have that?
That is the way, guys. Yes, that is the proper way to write it. I mean, it's an etiquette way, and it's just like how you get your radicals last and all that. It's it's just in the pantheon of writing out.
It's kind of like
Yes, it's like starting with the farthest out forks, and you're at a real fancy dinner and working your way in.
okay.
That's all it is. Yeah.
So let's say you have radicals and i's. Which one would go first?
I. And I'll show you that. We're going to get to that here in a second.
Wait, so I goes last, is there a number, like a normal number?
Yeah. You'll get used to it. It's really easy. What do you think you got to do here? Foil. Junk times junk, but it's not the same junk, so it's not going to be junk squared. But what we wind up doing is just foiling it out. So we foil out this one. Good old Billy binomial. It's Billy. Hurt Billy's feelings. Poor Billy. Billy did nothing to you.
He just died.
He was a figment of your imagination. You get negative 7. I know is it June?
Yes.
Plus
Yes,
14i
Spring, it's already raining.
plus 4i minus 8i squared. Combine like terms and worry about your I squared then. You already said that. So you get negative 7, 18i. Well, what's negative 8i squared become?
8.
Yeah, becomes 8. Because negative 8 times a negative 1 is positive 8. Ooh. Because remember, anytime you have an I squared, you rewrite that as a negative 1. So it becomes negative 8 times negative 1.
Wait, why is it negative 7?
What's 7 times negative 1?
Oh, okay.
Alright.
So your final answer would be 1 plus 18i.
Wait till see if you have it.
That's the proper way to do it again.
Wait, don't change it.
I know.
Maybe I should reconsider what I was.
Trying to call a dog or something? All right. Now take a look at what's in the parentheses. What does L look like?
That looks like
Oh,
a purple square.
Almost. It's a difference of squares. Very good. Yep. It's a difference of squares. When you had a difference of squares when we FOILed it out earlier, think back to what that looked like. The difference of squares came from a problem like this. X squared minus 4. There was no middle term. Was this a perfect square? Was that a perfect square? Was that subtraction? In that case, you wound up with x minus 2, x plus 2. You wound up the same terms with opposite signs. It's the same thing with imaginary numbers. It's the exact same thing. So if you FOIL this out long form, you'll see what happens. You get 36 minus 18i plus 18i, and then you get minus 9i squared. What happens to those middle terms? They eliminate each other out. So this is a trick thing that we wind up being able to do, because when we have imaginary numbers in denominators, we don't want that, so we're going to kind of do the same idea. We're going to multiply by conjugates. It's kind of doing the same process here. What's negative 9 times I squared then? 9. It's okay. So you have 36 then, plus 9, otherwise known as, there's your answer. If you FOIL all that out, you get 45. Yeah, Lori?
So every time you do this, you have to fill this out, or can you just go?
If you notice the recognized pattern, first term squared, last term squared, and you're adding it. It's fine. That works.
Wait, first, so the last term square would be, okay, never mind.
Because it'd be 3 squared, and then it's a 3i, so it'd be 9 squared, 9i squared. So it just becomes, instead of minus 9, it becomes plus 9. So by doing this, it's going to be, well, it's not know what, it's now what. I didn't realize it did that. You're going to be able to, well, it's another math etiquette thing, where just like before we didn't want radicals in the denominator, we don't want imaginary numbers in the denominator either. The easiest way to eliminate imaginary numbers from your denominator is to do just what we did. We multiplied by a conjugate. We multiplied by the same terms with an opposite sign. We basically created a difference of squares. So if I want to do that here, what would I have to multiply that denominator by to get rid of a middle term, get rid of that I?
1 plus 2i.
You're awesome! Look back to what we did. Look back here. When I multiplied these two together, opposite signs, same terms, what happened to the middle ones? The i's went away. The imaginary is lost. It's now the real world. Okay. Same deal. I can multiply this by 1 plus 2i. But if I multiply the bottom by 1 plus 2i, what do I do at the top? Same thing. Because, once again, what does this equal? 1. Right. All we're doing is multiplying it by a factor of 1. By doing so, we're not changing anything. Oops. We're just eliminating the I value by multiplying by some sort of a scalar. And that scalar value is 1. So you do the same process. You FOIL out. You get 1 minus 2i plus 2i minus 4i squared. What happened to the middle terms? They're gone. Negative 4 times I squared is how much? 4. So your denominator becomes 1 plus 4, otherwise known as 5. And now you just have to FOIL it out again in the numerator. And you do the same process. The numerator, you're fine. You don't have to worry about the I values in the numerator. That could be there all day long. It does not make a difference. So when you FOIL that out, same process. It's a 5. We have a 10I. We have a 3I. And then I have a 6, plus 6I squared. And I do the same idea by combining my like terms. I have 10, 13, and 6I squared, it's positive 6 times I squared becomes what? Very good. It becomes negative 6.
Yeah.
5 times 2? Yeah. 5 times 2I is 10I.
10 plus 13I.
Then I have 3I times 1 is 3I, so 10 plus 3 is 13.
Yeah, but it goes from 5 plus 10I to 10 plus 13.
Oh, I'm sorry.
All right.
Sorry about that. I did the same stupid thing second hour too. I'm sorry. I must have looked back at the 10 real quick and I just wrote it down twice. Sorry about that. So then you had 6I squared becomes negative 6. We okay with that?
Yeah. Yeah.
So now your numerator becomes negative 1 plus 13I, and you're done. And the I has gone out of the denominator. Same way that when we had, I don't know if you had one of these last night or not. If you have 2 over 3 minus root 2, do you remember what to multiply top model by? 3 plus root 2. It's the same basic idea. You're getting rid of the radical in the denominator by creating a difference of squares. It's the same process with these as well. Okay? It's the exact same process. Let me give you one more of these. Try that one on your own.
Nope.
Please?
No.
How about I say pretty please?
No.
The sugar on top?
Nope.
I am the pouting. Alright, whatever.
Is this going to be on our thing tomorrow?
Boy, is that negative I squared?
What's negative I squared? Well, what's I squared?
Negative 1.
So what's 1 minus a negative 1?
Oh, that's 2, not 0.
Look at her face. You have a denominator of 0.
You don't have a
It's
denominator
not,
of
it's
0.
not 0, it's 2.
How did that happen?
Because it's negative.
Watch your signs, and that's what's going to happen.
It's a double
You gotta be
negative.
careful. Yep, you gotta be careful with your signs here. So in this case, when you FOIL it out, the denominator is going to give you 1 minus I squared, which is 1 minus a negative 1, which is
1 plus 1.
otherwise known as
2.
2. That's where you'll screw up. The denominator here becomes 2. Okay? Numerator, you get 3 minus 3I minus 4I
Wait, what is
plus 4I squared. What's up? What's up, Hannah?
Yeah, 1 plus 1?
Yeah, because it was 1 minus a negative 1. So minus a negative is plus. I changed it.
Alright.
So now you get 3 minus 7I minus 4, which is negative 1 minus 7I. Okay. That's the mistake that most people will make. Watch your signs if there's no coefficient. And hopefully, you might pick up on the shortcut when you're multiplying by conjugates. There is one. Yes, ma'am. What happened with 4? It was 4 times I squared, so it's 4 times negative 1, so it became negative 4. 3 minus 4 is negative 1. Yeah, I just combined them up. Homework-wise, I believe I already posted it. I think it was these, as these were the right ones. I think I had that on both here and on the calendar. You double check the calendar.
Yeah.
Was it the same one? Okay. Yeah, same stuff. So, yeah, I'm going there. Hold on.
Oh, jeez.
That's a lot.
Same stuff here. Give me a second. I'll write it up on the. Actually, one of you guys write up on the board for me on the right there, and then I'll put it up on here because I was able to fit all of it on one sheet. You guys got it. 10 minutes. You can knock out half a dozen of these. What's that? Yeah. Give me 1 sec, okay?
Yeah.